also 1.2. That's like the triangle one. I actually really like those, but it's so hard to
Okay, let's start with the one that you drew, where I gave you 3 sides of the triangle. Those 3 sides were 10, 6, and 8. And you had to construct a triangle with those 3 sides. First of all, what can you tell me about that triangle? Scalene. Right, why?
Because all sides are different.
Good. Do you know, what else do you know about the triangle? Good. Can you prove that?
Yes.
How? That would prove it for that triangle. Go ahead. Oh, you need a 6 and 1. Okay.
Yeah, it's that one that you messed it up.
All right.
One of the two messed up.
Pretty close. Okay, good. Does that prove it for all triangles? No, why not? Is that you? Did you say no? Did you say no? Why is it no? Yeah, you can't measure every triangle. Okay, but for Tim's triangle, it happens to add up to 180 degrees. What other kind of triangle is that, Tim? It's got to be one of those 3. Which one? Hold on, while he's measuring, the rest of you measure the 3 angles in that triangle, please. In particular, measure the biggest angle.
Well, we know there's a 90-degree angle.
Torrin, what did you just say? What did you just say? Was that you talking? Oh.
What?
The 90-degree angle?
No,
Arthur, what did you say?
the 90-degree angle.
How do you know that?
Because of the second theorem.
Beautiful.
A squared plus B squared equals C squared. 6 squared plus 8 squared equals 10 squared. Therefore, it has to be a right triangle. One of the things that we talked about before I left was, what happens if it's not a right triangle? What if, for instance, you have a triangle that's 7, 4, and 10? Is that a right triangle? Lucas, you're saying no, why?
Because it's different.
Be specific. What's different about it?
The number, the length of sides.
Okay, so why is it not right then? Okay, anybody else? Yeah,
A squared plus B squared does equal C squared.
correct. I think that's what you were trying to say, yeah. 49 plus 16 is not equal to 100. Okay, so that means one of 2 things is true about this other triangle in blue. It's either acute or it's obtuse. Which one? We could construct it. We could take another piece of patty paper, draw a 7-centimeter segment, a 4-centimeter segment, make a triangle with 10 centimeters, then measure the angles and go from there. But there should be an easier way to do that. What do you got?
A squared plus B squared is less than C squared. It's acute.
Okay, hold on one second. Let me write that down.
If A squared plus B squared is less than C squared,
Acute.
it's acute? You think?
I wrote it down, but I don't remember. But then if it's the other way, if A squared plus B squared is greater.
Okay, hold on. You should have another triangle where I gave you the 3 angle measures. in just the three angle measures. There's like a 45, a 75, and something or another. You got that one? Which one is it?
This one.
45, 75, and 60, yes. Okay. And everybody's triangle should be the same shape. We'll talk about that particular triangle later. However, what kind of triangle is that? Acute. Is there any possibility that that's not an acute triangle? No, because we know the three angle measures. We know that there's 45, 75, and what's the other one, 60? So we know that that's an acute triangle. So Mia, if we take that triangle that you have sitting in front of you, if we apply the side lengths, we should get that to work, right?
Plus you tell
No, because I just did it and they're equal.
Well, let's find out. Using your 6 and 1s, measure the three sides of that triangle with the 45 to 65 and the, whatever they are, angle measures on it. In centimeters, please. By the way, everybody's measurements will be different. We'll talk about that in a little bit. All I need are the three measurements from one person's triangle. Joe, what do you got?
No, I was asking if I could have another protractor.
Did you just break one of my protractors?
No, I was.
That'll be 1250.
I'll put it.
Trying to break this one.
It's not like we're making money here at Prospect High School. We can't afford 6 and 1s. We can give everybody an iPad, but we can't afford 6 and 1s. What's the matter? Yeah, that's how we pay for the 6 and 1s, is we overcharge for lunches. You think a pizza puff normally costs $4.50? All right, how long are the sides? Amy, how long are your sides on your triangle? No, not the angles, the sides. Okay.
I can't hear you. Shh. 7?
Yeah.
And the third? Okay. And we know that that's an acute triangle, right?
Yes.
Okay. Does it satisfy Mia's suggestion? Is 5 squared plus 7 squared less than 7 squared?
No. So is it possible that you got those confused?
Yes.
Okay. So that we should be here, which would mean, Mia, that a squared plus b squared being less than c squared would be? Okay, let's verify. You have a triangle in front of you that's obtuse. One of your constructions gave you an obtuse triangle. Measure the three sides on that one, please. You may already have at least one of those distances. So pick the one that you're sure is obtuse and measure the three sides without breaking my 6 and 1. Sure.
6.
What's the word for this?
Measure the obtuse triangle. This like this.
Try to find out.
Yeah.
You're a hot mess, aren't you?
I don't know about that.
You got it?
Chief, it's confused. Let's see, Mom.
Thomas, what are your three sides?
Say it again, please. 6, 10, and 6. Okay. Is 6 squared plus 6 squared greater than, whoops, no, we had that backwards. Less than 10 squared. Yeah, so therefore it's obtuse. All right. That was a long-winded way of coming up with these calculations.
So now, if we know the three sides of the triangle, not only can we determine if it's scalene, equilateral, or isosceles, but we can also determine what kind of triangle it is by its angle measures. Okay, is it right, acute, or obtuse? It's got to be one of those three possibilities. Is it equal, is it greater than, or is it less than? The difficult part for you is going to be remembering which is which. Okay. If you get stuck, and you're on a test or a quiz or whatever you're doing, and you can't remember which of these two apply, there's an easy way to remember it. Go back to an equilateral triangle. What else can you tell me? Well, what can you tell me about an equilateral triangle? All sides are equal, so let's assign some side lengths here. Let's call it 4, 4, and 4. Is that triangle acute or obtuse? Acute. All equilateral triangles are acute. Therefore, this must apply. So, in other words, is a squared plus b squared greater than or less than c squared? It's greater than. So that can help you remember which is which. Obviously, you'll remember if a squared plus b squared equals c squared being right. That's the easy part. The hard part is the acute. Okay? All right, let's go back to this one, the 10, 6, and 8. Get rid of this. You were supposed to have done this already, but in case you didn't, compare your triangle with your group's triangles and see if they match up. In other words, can you flip your triangle around to get it to match your group's triangles exactly? Do they pair up? Hold them up to light, do they match? It might require that you flip them over a little bit, but make sure you have the correct correspondence. Just the one with the 10, the 6, and the 8.
Just on the 10, 6, and 8. Wait,
Just the 10, 6, and 8 for now.
You said just the 10, 6, and 8. This is the one that looks really bad. Yeah. That's the string. Oh, no.
Okay, but you still got 10, 6, and 8. So then it gets matched up. You want that one.
Doesn't have to be exact.
Do they match? Yes. And in fact, if you take your triangle and go to anyone else in the room that did the construction correctly, they will all be the exact same triangle. So why do we care? Good answer. Let's go to this statement. This is called the triangle. Whoops, I forgot something. This is called the triangle congruency statement. And there are 6 chunks of information wrapped up in that congruency statement. What are the 6 chunks of information?
All 3 sides match up with the other ones, all 3 sides. They're the same with 8.
Good. 3 angles, 3 sides. From that statement, let's start with angle X. Which angle does X correspond to? P. Which angle does Y correspond to? Q. And Z would correspond to R. In other words, we have this, X, Y, Z, and P, Q, R,
So therefore, X would go to P, Y would go to Q, and Z would go to R. What about the side lengths, Tom?
They're the same for
Be specific. Which sides are congruent to which sides?
X and Y and P and Q.
Good. So the first two here correspond to the first two there. All right, what else?
Y and Z and Q and
Y, Z, and Q and R. The second and third, and then the last pair?
S and Z and P and R.
First and third. First and third.
Okay, all from that one statement called the congruency statement. We can also go the other way. We can take a triangle with the stuff congruent and write the congruency statement. But the order becomes very important. If I have one of those triangles listed in the wrong order, we're going to have the wrong correspondence between the sides. That's 6 chunks of information, and it's too much. Every time if I have to prove 2 triangles congruent, if I have to find 3 sides and 3 angles, it's going to bog down way too much. So what we want to do is come up with some shortcuts, and that's what the patty paper did for us. So for instance, we come back to this, 10, 6, and 8. 24 of you drew a triangle with side lengths 10, 6, and 8. All of your triangles look identical. Therefore, it's a pretty safe assumption that anytime you're given just the 3 sides of a triangle, those triangles are going to be congruent. And in fact, they are. That's called the side, side, side method. And that's method number 1. If you're given 3 pairs of sides between 2 triangles, the triangles have to be congruent. And we had some other examples. So there was one you had that, I don't remember which triangle it is, but it had 2 sides and an angle. Yes? Which one is that?
Is that,
I believe it was 2.
Okay, what are the measurements, Tim?
The angle was 45,
Uh-huh.
and
6 and 8 or 10 and 8? I don't remember. 6 and 10. Okay. Within your group, find that triangle and see if yours matches with everyone else in your group. If we can get everybody's triangle look the same, we now all of a sudden have another method. You think that's triangle number 2? Match. That's the wrong triangle. That's 6, 8, 10. You went over 45. All right, hold on. Put your patty paper away. It's too much confusion. On that new piece of patty paper. Yo, let's stop the background chatter, please. I'm tired of talking over people. Construct that triangle. 45 degrees, 6 centimeter segment, and a 10 centimeter segment. Once you get it constructed, compare with everybody else's in your group. See if they match. As you're doing the construction, label the measurements that you measure. Measure the 45 degree, or mark the 45 degree angle
Mark the 6 centimeter segment, mark the 10 centimeter segment. For the other two. Do you want that? Did you guys check? Did they match?
Oh, you did your 6 centimeter in a different spot. Yours does not match mine. The 10 centimeter side. Mine's all about. Yeah, they don't match. Zach, did you do yours?
Did they match? That's why it says 45.
Oh, no wonder. Heck was I
I'm guessing that everybody's triangles matched. However, there is a snafu.
That doesn't necessarily need to be the case. I'm guessing most of your triangles look like this. Yes? Beautiful. Did anybody not construct it that way? Good. So we're all on the same page. Now, if that first one was called side, 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 what do you figure this second one is called?
Side, side, angle.
Angle, side, side. Okay? Angle, side, side, or what? Or side, side, angle, or side, angle, side. Okay? 3 possibilities. Now, there's a reason why I wrote the word ass on the board, which we'll get to in a second. Okay? That's actually what's called side, angle, side, because the angle is between the 2 sides. That's called being included. It's an included angle. Okay? So this is side, angle, side. And it's method number 2. It does in fact work. However, there's a different way you could have constructed the triangle. You could have done it this way. This is horrible, but you get the idea. I could have put the 45-degree angle over here. Now, the reason no one did that is because it's difficult to construct. It doesn't come naturally. It was easiest to just draw a 45-degree angle, measure down one side 10, measure down the other 6, connect the dots. This, however, is angle side side. Angle side side doesn't work because 2 reasons. Depending on where I put this angle, if I put the angle here, it's one triangle. If I put the angle over here, it's another triangle. Therefore, this is one of them that doesn't work. And the reason I write it that way is because then it makes it easier to remember. If you try to use angle side side, you will make an ass out of yourself. Get it? Good. So don't use angle side side. That's 2. Let's see. What else do we have? You should have one that involves
2 angles and a side? Yeah, what are the measurements?
45, 8, and 80.
And?
And 8.
And 8.
Side is 8, yeah.
I will take that.
Okay, your goal on this one, before you start constructing, listen first. Your goal on this one is to realize that there are 2 different triangles you can draw, and see if you can draw a triangle that doesn't match the rest of your group. Assuming, of course, you're doing the construction correctly. Okay? Try that.
No, we'll just make this one.
80. You're all set. So close enough that it would just be written out. Okay. Did anybody manage to draw a triangle that doesn't match someone else's? Okay, so I'm guessing what happened is most of you started with an 8 centimeter segment. On one side of that segment, you slapped up a 45-degree angle. On the other side, you threw up an 80-degree angle, and then marked where they intersected and got your triangle. No? You did it differently?
I'm gonna make, I made this.
Okay, hold on, I'll come back to you in a second. That's exactly what I did. Okay. What method would that be? If the first one's side, 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 the second one's side, angle, side, what's going on here? Angle, side, angle, or angle, angle, side?
Angle side, angle.
Angle, side, angle, correct. This is method number 3. The side is included between the two angles. In other words, it's between the two angles. Did you get yours to work out?
Yes.
So yours is different.
So Emily did the following. She's got an 8-centimeter segment.
And then the 45 on this side.
Then she put a 45-degree angle down here. And then somehow she engineered it to find the point up here to give you, well, that's not even close.
80 at the top.
Somehow to put that 80-degree angle in here. What method is that? Side angle, angle, or angle. We commonly call it angle, angle, side. Now again, angle, angle, side does work. Unlike ASS, which doesn't work, it's the one that gets triangles that don't match. If you did the construction method the same way that Emily did, your triangle would match. So given those 3 measurements, you can get 2 triangles that match up. Okay? Last one. Let's do another new construction here. Let's go 30 degrees, 70 degrees, and 80 degrees. Same procedure, draw your triangle with the 3 measurements, and then compare your triangle to everyone else's. While you're doing the construction, by the way, what method would this be? Angle, angle, angle. The only question is, does it work? Maybe is a safe answer.
Oh, yeah.
Oh, really? So do my 7th grade. Now let's start this.
Man, this makes my baby
See if this makes an 83. It works.
Does it work?
Yes. See if I
I'm not saying you constructed it wrong. I'm saying that they're not the same triangle.
Mine's smaller.
Okay, so this group just finished, and I was comparing their triangles, and what was true about the triangles? Did they match? Are they the same shape? Let me rephrase my question. Are they the same size?
No.
Okay, are they the same shape? Yes, just one is bigger or smaller.
Yes.
Hopefully you found the same thing. So therefore, does angle, angle, angle work? No. So far we have 4 different ways to prove triangles are congruent. Okay, so now we start looking at how we can apply this. Up until we came up with those shortcuts. If I wanted to prove that those triangles are congruent, I have to prove all 6 parts are congruent. All 3 sides, all 3 angles. However, we can use some shortcuts. We want to do 2 things. Well, we want to do a number of things. Number 1, are the triangles congruent? Number 2, if so, why? Which of those theorems tells us they're congruent? And number 3, we want to write a triangle congruency statement between those 2 triangles. Okay, so question number 1, are the triangles congruent?
Yes.
Okay, question number 2, why? Which of the scenarios in the previous screen, side, 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 side angle, side angle, side angle, or angle, angle, side, are congruent, Emily?
Side, side, side.
But I only have 2 pairs of sides congruent.
The third side, it's the same line, so they have to be.
Correct. The way you show that in a picture is draw a little circle on it.
Oh, wow.
Okay.
That segment, as she said, is congruent to itself. Okay? Yes, they're congruent. They're congruent because of side, side, side.
Now the hard part, the congruency statement. What do you got, Emily? Triangle blah, blah, blah is congruent to triangle.
But is X like that point?
X is the corner up here, yeah.
Okay. So triangle XQZ is congruent to
Triangle XQZ is congruent to triangle
XY.
XYZ.
Is she right?
So is this angle equal to that angle? Does X go to X?
Okay, well, look at on the left triangle, angle X is between the side with 2 marks and the side with the circle on it. In the triangle to the right, angle X is between the 1 mark and the circle.
ZYX.
You want to change that to be
ZYX.
ZYX.
Wait. X cubed.
So you're saying X goes to that Z,
Yes.
Y goes to Q, and the Z angle here goes to the other X angle here.
Yeah.
Good, well done. Okay. All right, let's do another one.
Question number 1, are those triangles congruent? Yes. Question number 2, why? And by the way, there's a couple different ways to do this problem. Side, 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 angle, side, angle, side, angle, 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 side. Side, side, side? No. No, no. Angle, side, angle. Yeah. No. No. Angle, side, side.
Let's start with that chunk of information.
What does it mean when G bisects FO? What's they, Lucas?
The 2 sides of the triangle. So, or the big triangle. I don't know, but like.
Be specific and tell me which 2 sides are congruent.
G is equal to OG.
Those? Yeah, FG and OG, the original gangster. Okay. Follow? Okay, so then RG is congruent to itself, so why are those triangles congruent? Side, 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 it's just like the last one. However, how big is this angle? 90 degrees. So if I get rid of this stuff in the middle, now what have I got going on there? No. Angle side side. And what did we learn about angle side side? Doesn't work. So we just created a problem. Because doing it the first way, we know that the triangles are congruent. They have to be congruent. But now we're looking at another method that says, whoa, 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 those can't be congruent because we just use angle side side. So we have to be able to work that out. Before I explain that, another side note, if I left this in here, we could also use side angle side with the right angle. So there's another reason why the triangles have to be congruent. The problem that we created is a very special case of angle side side called HL, hypotenuse leg. So we do have a fifth method for proving triangles congruent. HL would seem like you only need two chunks of information. You need the hypotenuses congruent, and you need a pair of legs congruent. However, there is a third chunk of information. Where do you get a hypotenuse? Right triangle. So we have to establish also that we have a right angle in there. Without those right angles, we have angle side side, and like we said before, angle side side doesn't work. So if I come back here, we've got another method to add here, hypotenuse leg, which is method number 5. The trickiest part for you is going to be differentiating between side angle side and angle side side, and differentiating between angle side angle and angle angle side. Is the side between the angles? Is the angle between the sides? Especially for these two up on top, because one of them works and the other one doesn't work. If you get these two confused, it's not the end of the world. You still have the fact that the triangles are congruent. We just may have used the wrong method. The top one, however, if you get them confused, you're going to have a big problem because the triangle won't be or should be congruent. Okay? Questions? We've got triangle congruency statements. We've got all the information that you can get from the triangle congruency statements. We have 5 new methods to use to prove triangles are congruent using shortcuts. We have 2 methods that don't work. Okay. So now it's just a matter of practicing enough so that you can identify each of those possible components. 2 homework assignments tonight. Day 3 and day 4 will get us all caught up. We'll be back on track from everything that we missed for the 4 days yesterday. And the assignments aren't that lengthy and they're not that difficult, so you should be okay.